Okay, so let's take a look at your homework. Hopefully it wasn't too bad. Number 1 says, write the components for any vector that would be parallel to vector A. Now there's a couple of ways you can write vector A. You can write it with the arrow over the top, or you could write it bolded. So you'll notice in the sheets I give you that it's bolded, because that was easier than putting an arrow over the top. Okay, so any vector that's parallel to A. If you think back to when we talked about multiplying a vector by a scalar, we said when you multiply a vector by a scalar, then what you get out is a vector that's parallel to that vector. So really, I can multiply A by any scalar, any number, and I will get a vector parallel. So my new vector could be 10I plus 12k. I could multiply by 2. Or I could multiply by 3, and it could be 15I plus 18k. Or I could multiply by a half or 1,000. Any vector will be parallel to the original vector if you just multiply it by a scalar. That easy. Number 2, A, wants you, so it gives you vector A and vector B, and it wants you to find 6A plus 2B. So 6A plus 2B. So in other words, 6I plus 6J plus 6K plus 8I plus 12K. Right? So I've just multiplied this guy by 6, this guy by 2. 6 plus 8 should be 14I. There's no other J, so this will just stay as 6J. And 6 plus 12, 18K. And that's it for 2A. For 2B, it is 6A minus 2B. 6A minus 2B. So that'll be 6I plus 6J plus 6K minus 8I minus 12K. So I should get negative 2I plus 6J minus 6K. And notice that I always write it IJK. Think about an ordered pair. It always goes XY set, right? Like you wouldn't switch that around because you would screw up people. So really this is the ordered pair, just written with IJKs. Okay, so that was it. Those were the only 2 questions I asked you to do last night. Why? Because we need to go further before you can do more. And now we will go further. So adding vectors together, we got pretty good. We learned our unit vectors. It's now time to multiply vectors together. And if you remember from grade 11, I had told you there were 2 different ways to multiply vectors together. The first one, which is the one we looked at, and I wrote number 1 here for the first way, but it's really number 5 if you want to keep numbering from the beginning. The first way is called dot multiplication. And it's often known as the dot product or the scalar product, because the number you get out is a scalar, not a vector. Okay? So it's when you dot multiply 2 vectors together. You think back to our work equation from grade 11. W is equal to F dot delta D. That was the dot. And we went from that to say, well, W is really equal to F delta D cos theta. Okay, so this is an example of dot multiplication. So a long time ago, even before I was around, they defined dot multiplication as, they said, okay, if you have A dot B, then that is equal to the absolute value of A times the absolute value of B times the cosine of the angle between them. Okay, this is what we define dot multiplication to be. This will give us a scalar. Now, remember the absolute value of A and the absolute value of B are really just the length of the vectors, or the magnitude of the vectors. So again, if you think back to the work equation, right, we multiplied the size of the force by how far it moved and then cosine of the angle between them. So this theta is always, always, always the angle between the two vectors. Okay? All right. So let's think about work for a minute. So I have a box on the surface, and I'm going to pull upward at an angle with my force. Okay? But I'm going to move the box this way. Imagine that straight, would you? Well, really then, what's happening is there's only a component of this force that's pulling it in the direction I want to pull it. Part of it is kind of being wasted because part of it's lifting the box off the ground. So it's really just this component, and I'm going to call this component Fx just because it's going in the x direction. It's only this component that's really doing any work. So it's like the work is really Fx times delta d. Well, what is this Fx? Well, if I drop my legs down and form a right angle triangle, and if this is theta, well then this Fx is the adjacent side, and F is the hypotenuse, so you would do cos theta was equal to Fx over F, so Fx is equal to F cos theta. So if I put that in here, then it's like F cos theta delta d. And if I move my cos theta to the end, I have my equation for work. So really what we're saying is, when we do dot multiplication, we're only looking at the component of one of the vectors that's going in the same direction as the other vector. Okay, so we say it's like the scalar projection of A onto B, or it's the length of vector A, the length of the component of vector A that's acting in the direction of vector B, right? So really we're finding the component of the one vector that's acting in the same direction as the other. Okay? Makes sense? So that's what we're saying here. So that really you were doing this part when we were doing work. All right. So a little note to self. And what we get out is always, 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 always a scalar. Okay? Now think about the work equation. Remember we had when would you get maximum work and when would you get minimum work? And if you remember, we got maximum work when you pulled in the same direction, when F and delta D were going in the same direction, when the angle between them was 0, cos of 0 is 1. And we got minimum work when you were pulling perpendicular, because the perpendicular is 90 and the cos of 90 is 0. So if we think about that in our IJKs, or in our like with just regular vectors, then when we do A dot A, they're going in the same direction. And so we should get like absolute value of A, cos of 0. And cos of 0 is 1. So this will just be absolute value of A squared. Okay? But if we did like if we did I dot I, then it would be the absolute value of I times the cos of 0. So what's I? Well, I is a unit vector in the x direction. What's its magnitude? Because absolute value is really like the length of I. What's the length of I? The length of I is 1. So 1 times the cos of 0 should be 1. It could be 1 squared if you want, but it's still going to be 1. Okay? Well, how about I dot j? That would be the absolute value of I, or the length of I, which is 1, the length of j, which is 1, times the cosine of the angle between them, which is 90. Cos of 90 is 0. And so I dot j is 0. So it goes back to that maximum and minimum work. Okay? So we could say if the absolute value of A is not equal to 0, I'm going to run out of time, and if the absolute value of B is not equal to 0, but A dot B is equal to 0, what does that